This is Advanced Algebra, Unit 4, Day 5. Monday, December 11th, a B day, or Tuesday, December 12th, an A day here. So, today and next lesson, you'll have some video to watch here, going over some of the stuff. So, at this point, pause it, do the warm up if you haven't done that already. So, looking at this one, A, B, and C, simple change it here. So I'm going to change it from log form to exponential form. The base of the log becomes the base of the exponent. So x is 5. In B, base of the log becomes the base of the exponent. We have 8 to the 1/3. So two things to worry about here. The negative, what does the negative do? And then what about the fraction here? The negative makes it 1 over 8 to the 1/3. 8 to the 1/3 means 8, and then the third root of that, which is 2. So it's 1/2. In C, base of the log becomes the base of the exponent. The base of the exponent becomes the base of the log. 3 to the x is 81. So x is 4. In D, I do the same thing. 4 to the x equals 100. But in this case, well, 4 to the x. Well, that's going to be 4 squared is 16. 4 to the third is 64. 4 to the fourth, that's over 100. So it's not something that we can do by hand yet. So what can we do? We can graph it. So we're going to graph both sides. We're going to graph the y equals 100. That's a horizontal line right there. We're going to graph 4 to the x. 4 to the x, that's exponential. We know it's exponential growth because of the 4. The 4 is greater than 1, so that's exponential growth here. So we're looking for the intersection. How do I calculate the intersection again? Second, calculate, and then intersection. We get about 3.32 for that. Then in 2 talks about the Richter scale. We looked at that last class, the Richter scale, the decibel scale. When we think about the Richter scale, things we have to remember that it's a factor of 10 there. So I take the difference between the magnitudes of the earthquakes, that's 1.6, and then it's 10 raised to the 1.6. So that gives you 39.8. So the magnitude 5.8 is 39.8 times as intense as the 4.2 earthquake. Typically at this time we'll go over homework. However, I will collect your homework when I get back, so you can hang on to that. We'll just go on to the lesson here. If you do have any questions, if the sub can answer it, great. If not, try to find another math teacher during resource time or during before school, something like that. So, two things we're doing today. One, going over some properties of logs, and then how to solve some logs a little different way here. So, the first one, the properties of logs. They come from our power properties here. Remember, because they are inverses, so a lot of the properties are the same here. When I am multiplying, I added the exponents. So when I add logs, I multiply the x and the y together. Same thing for division, that's subtraction. And then power to a power is really multiplying, so the number, the exponent gets moved out in front. That is a big one that we'll look at quite a bit. And then just below that, in the star, that property, it's kind of an intuitive one here. We start with this idea. 3 to the x equals 3 to the 5th. Now, I hope that everybody can tell me that x is 5. Why? Well, when the bases are the same, base of 3, base of 3, we know that the exponents have to be the same. We use that same idea with logs here. So, log base 3 of x equals log base 3 of 5, let's say. What do I know now? If I have log equal to log on both sides, then the part inside has to be the same. So x has to be 5 there. That is known as our one-to-one property. And we'll see that quite a bit as we go on as well. So, how do we use some of these additional properties, well, these I wouldn't say you'd have to memorize. I would say the first three you should definitely know, memorize. You got to actually have those down. These you can derive just by doing it, just by changing log to exponential, exponential to log. So some of them, if I look at number 2, log base a of a, whenever the base and the number are going to be the same, so log base a of a, log base 5 of 5, log base 2 of 2, that is always going to be 1. If I look at 3, if I take the x and the exponent, I bring it out in front, that's x times log base a of a. Well, log a of a is just 1, so it's x times 1, or just x here. And then if I look at number 4, another example of the one-to-one property. So then, if I look to the right side, then we have some other ones with ln, the natural log, log with a base of e. So if I look at number 1, log base e of 1, well, change it. If I don't know what that is, let's say that's x. So e to the x is 1. Well, what does x have to be? X has to be 0. Therefore, yeah, natural log of 1 is 0. And the log of 1 is 0. If I look at number 2 and number 3, those ln of e, log base e of e. When the base and the number are the same, it's going to be 1. If I looked at 3, if I bring the x out in front, log base e of e, that gives you 1 there. You can kind of think of like they kind of cancel each other out a little bit. So where do these come from? What mathematician said, I declare that these are true, so. No, well, there are proofs here. So we're going to go through some proofs. Control your excitement. Good. All right, so look at the first one here. We start with this, b of x to the equals m, b of y to the n. If I change them to log form, that gives me log base b of m equals x, log base b of n is y. So again, I just changed it to log. Now, at this point, well, m is b to the x, n is b to the y, and I can multiply those together. So m times n equals b to the x, b to the y. Now, if I look on the right side, how can I simplify b to the x, b to the y? Well, they are multiplying, so I can add the exponents. b, x plus y. So at this point, this is all stuff that you've done. So now in 3, where do we go from there? So if I have that, I'm going to rewrite it back now in log form. So the base of the log becomes the base of the exponent. Base of the exponent becomes the base of the log. So b x plus y, oh yeah, it becomes log base b of mn. So I change to log again. That leaves me with log base b of mn equals x plus y. Now, typically x plus y, we don't want to leave it like that. We want to just write it in terms of m and n, like the left-hand side. So how can I get rid of x? We use a substitution. X, if we look at step 1, is log base b of m. So wherever there's an x, I'm going to put in log base b of m. Wherever there's a y, I'm going to put in log base b of n. So what happens? We've proven that first log rule here. That when I am adding log base b of m plus log base b of n, I can write those together as one logarithm, log base b of m times n. I can also separate them as well. If I had log base b of mn I can write it as addition there. So again, addition there means I multiply m and n together to make it with one log. Again, that comes from the first property there. You look at the power property, logarithmic property, those are the same. We can do the same proof for the second and the third one, here and here. The third one we use quite a bit. And there's the proof of it. That's division, quotient. We're not going to go through it. Okay? If you want, you can take a look. It's on Moodle. You can pause it and look through it and stuff. We want to be able to use these properties here. So how can I write these as one log? Take a second, pause the video, give the first four a shot here. How can I rewrite them? So taking a look, the first one. It's addition. So if it's addition, I can multiply the numbers there. So 5 times 2, I get 10. So that's going to be log 10. In number 2, it's subtraction. So that's going to be division. 96 divided by 3. That's going to be log of 32. In 3, I'm going to have to do two things. First thing, I'm going to have to move the 2 up. So the 2 goes back up there. That becomes 5 squared. And then 5 squared is 25. And now it's addition, so I can multiply 5 squared and 4 together. So 25 times 4 gives me 100. In number 4, my base is 1/2 here. They're the same. So it's subtraction, which means I can write it as division here. That's going to be log 1/2 of 40 over 5, or log 1/2 of 8 here. At this point, it didn't ask you to evaluate it, so you could leave it like this. Could you evaluate it? Sure. I could simplify this. I would set it equal to x, change it from logarithmic form to exponential form, and what do we know? The base of the exponent becomes the base of the log becomes the base of the exponent. 8 equals 1/2 to the x. So what do we know? X is going to have to be negative in order to flip the 1/2 to be a 2. And 2 to what power is 8? I think that's 3. So I think I should get -3 there. And I could go through and prove it there as well. And there's the 1/2 raised to the -3. Yeah, the negative flips it. 2 to the third is 8. So we have a little downtime here for a second. Okay, pause it. Give the next ones a shot. We're going to solve these. So work to get x alone. All right, so in this one, first thing I see, I'm going to have to move the 3 up. And it's subtraction, so that's going to be dividing here. So I have log 2 to the third, that's 8. And now it's subtraction. Okay, so subtraction means I can put those two logs together. I can write it as a single log of 16 divided by 8, or log of 2. Now, look, I have log base 5 of x equals log base 5 of 2. If the logs are the same, then the inside has to be the same, our one-to-one property here. So what do we know? X is 2. In the next one here, first thing, I'm going to move the X up. So it's log. Now I'm going to change the form from log to exponential. So that's 8 to the x equals 4 to the third. Notice, what is 4 to the third? That's 64. 8 to the x. Okay, so 8 squared, that's 64. Yeah, so x is 2 there. In 3, first thing, put them together. It's addition, so I multiply. That's log 14 equals log of x. The logs are the same, so 1 to 1, the inside parts has to be the same. X is 14. In 4, it's addition, so I multiply the x's together, I get x squared. At this point, I do not have logs on both sides, so I can't just say x squared is 1. I have to change it into exponential. X squared is 6, so x is the square root of 6. Notice it can't be plus or minus here. I can't have it as negative here. All right, 5. So 5, subtraction. Subtraction means what? Division here. So I divide it. I have log equals a log. That means that the inside parts have to be the same. So 4x over 3. So 4x plus 3 over x equals 5. From here, I'm going to multiply both sides by x. So I get 4x plus 3 equals 5x. When I move the 4x over, I get x is 3. So these we'll do together, especially 1, 2, and 3. So 1, 3 to what is 81? Okay, that's 4. And number 2, those I'm going to have to move the 75 over, looks like. So I get 5 to the y is 125. So I think y is 3 there. In number 3, I'm going to have to get rid of the 4 first. So I divide by 4. I get 49, so x is 2. Then in 4, 5 to what is 43? 5 squared? No, that's 25. 5 to the third? No, that's 125. Shoot, we don't know exactly what it is. So what can I do? I guess I could graph it. I guess I could do guess and check. In fact, if I did guess and check, I know that x is probably between 2 and 3 because 5 squared is 25. 5 to the third is 125. So if it's between 2 and 3, I don't know, let's try 2.5. So we can do 5 to the 2.5. Again, pull out your calculator, punch some buttons, go from there. So, funny story, I already did this recording before. Unfortunately, I was doing it with the wrong mic, and it came out horribly. So now I'm redoing it again. So that's a half hour of my life that I'm never going to get back. So that's really exciting for me. But for you guys, at least it's a clearer recording than the garbled mess it was. So anyway, 5 to the 2.3 is 55. 5 to the 2.4 is 40. So let's see. 5 to the 2.3 That's going to be about 40, I believe it is. So we know that it's between 2.4 and 2.3 because I wanted it to be 43. 2.35 maybe? So we could do guess and check and kind of process of elimination or work our way through that. Question is that takes a long time to do. It's not very efficient, and we don't get exact answers here. It's kind of a low road method to do this. How else can I go about doing this? Well, other than graphing, we haven't talked about how we can algebraically do it. We've said, well, we can't really do it algebraically. That's until now. So, in this one, we're going to solve for y. We're going to get that y alone. The y is in the exponent part. So whenever you have the variable in the exponent part, this is one of the things that you will be able to do. So the first step in this, take the log of both sides. So that means log a to the y equals log of x. Take the log of both sides. Second step, use the log property with a power to bring the y or the variable out in front. Third step, divide by log of a. So y equals log of x over log of a. Says that we use base 10 or base e. Why do we use base 10 or base e? Because we have the button on our calculator. And we can use that to approximate it. So I can use log, or I could do the same thing and use natural log, ln. Either will work. And I do get the same thing. So let's go back to the problem. 5 to the x equals 43. Take the log of both sides. First step, take the log of both sides. Second step, bring the x or the variable out in front. X times log of 5 equals log of 43. Third step, log of 5 is just a number. So I divide by the log of 5. So I get log of 43 over log of 5. That's my exact answer. My approximate answer, we thought it was like between 2.3 and 2.4. And it was 2.336, blah, 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 blah. If I wanted to round it to the hundredths, that'd be 2.34. But that's my exact answer. And that's my approximate, my decimal approximation. Notice I do the same thing with natural log, ln. I took the natural log of both sides, bring the x out in front, divide by ln of 5. I should get natural log of 43 over natural log of 5. So in your calculator, go ahead, type in ln of 43 divided by ln of 5. See what you get. Do it. Seriously, do it. We get the same thing. So no matter if you do the log or the natural log, you do get the same thing. Which one do you do? Whichever one you want. So in number 1, how am I going to get the x out of there? I'm going to take the log of both sides. Now, x minus 1, I can bring that out in front. Now I write it as x minus 1 times log of 3 equals log of 23. Log of 3 is just a number, so I divide by the log of 3. And then I have x minus 1 on the left-hand side. How do I get rid of the minus 1? I add 1. So x is log of 23 over the log of 3 plus 1. If I want the decimal approximation, I could do that as well. That is 3.854, So about 3.9. All right, so next one. Next one, I'm going to use natural log, ln. Why? Why not? You can do either one. Doesn't matter. So I take the natural log of both numbers, both sides. I bring the x out in front, and I divide by the natural log of 3. So I get x is the natural log of 241 divided by the natural log of 3. That gives me x is approximately 4.992 dot, 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 dot. In 3, the variable's there, so I have to do a little bit before I get the variable out of the exponent. That means I'm going to move the 14 over. It's minus 14, so I'm going to add 14. I'm going to divide by 3, so I get e to the x is 25 over 3. At this point now, how do I get the x out of the exponent? Well, I can do the log or I can do the natural log. The advantage of using the natural log is this. The e there. ln e to the x is ln of 25 over 3. And the x can come out in front. And ln of e is really just 1 because it's log base e of e. Again, log base e of e or ln of e is just 1. So I get x is ln of 25 over 3. And again, I could take the decimal approximation. That would be fine. X is 2.12. All right, so look at these for a second. Which of these equations would require taking the log? The key, where is the x? In the first one, x is in the exponent. Yep, I'm going to have to take the log of that one. In B, well, the x isn't in the exponent, so I'm not going to have to. I just rewrite it. E to the 0 is 1. All right. That's pretty easy to solve then. In the last one, I rewrite it. X to the 5th is 27. How do I get rid of the 5th? Raise it to the 1/5 power. The 5th root, basically. X is the 5th root of 27, whatever that happens to be. Again, you can punch it in your calculator, figure it out. In A, so how am I going to do this? I'm going to take the log of both sides. Log 11 to the x equals log of 570. I bring the x out in front. I divide by log of 11. And there's my exact answer here. Log of 570 over log of 11. So, the closure here. Think about these for a second. Hit pause. And then we'll go over them. So the first one, it's addition. Addition, that means I'm going to end up multiplying the 4 and the 5. I should get log of 20. Eventually, when it writes. Come on, write it. Write it down. There we go. Log of 20. In B, it's subtraction, so it's going to be log of 30 over 3 or log of 10. And in E, it's going to be log of 36, 6 squared. So in number 2, what strategy is used to get the x out of the exponent? I take the log of both sides. That allows me to bring the x out in front. All right, number 3, algebra problem. How do I solve for x? What am I going to do? First thing, multiply by n. 2, subtract r. Third one, it's multiplying by w, so I'm going to have to divide by a negative w. And then that leaves me with a raised to the x minus 2. So I'm going to take the log of both sides. Then I'm going to bring down the x minus 2. And then I'm going to divide by the log of a. So right now I have x minus 2 times log of a equals whatever. I'm going to divide by the log of 2, or log of a, and then add 2. That'll get my x alone. So remember, what are the steps here? Okay. One thing, you don't have to get the stamps. Okay, the answers are up on the board here, front board, back board, and the side, either the board or the drawer there, the cabinet. So, one last thing, solving exponents. What do we do? Well, first thing, use inverse operations to get the exponential part alone. We want a number raised to the x equals something here. So then I can take the log of both sides of the equation. After I take the log of both sides, then my next step is to take and bring the variable, in this case x, down out of the exponent. And I can do that because of the power property. And then finally, after I get that down, I'm going to divide by the log of 3 here. I'm going to use division. So you have the rest of the time to work. Okay. Last thing, before you get too involved here, let's have the sub hand back the quizzes. You guys know where they are. If you didn't fill out the half sheet, fill that out now. You can take that with you as your kind of remembrance about what things you have to practice. Okay. The practice sheets are on Moodle, so get those in. We'll start doing corrections the week I get back, and we'll start doing the quiz retakes then. If you have any questions, you can always ask another math teacher. Mr. Marks, Mr. Fritz, Miss Kraft can all be helpful as well.